In the last lecture, we have seen 4 different methods of preparation of phenol. This is one more method from aniline, that is C6H5NH2 or aminobenzene. Aniline on diazotization. Sir, what is diazotization? Reaction with sodium nitrite NaNO2 plus dilute HCl that gives HNO2 plus NaCl. Of course, plus one more molecule of HCl in ice cold solution. That NH2 group of aniline is converted into benzene diazonium chloride aromatic ring on its top N2Cl or N positive triple bond NCl negative. This conversion of aniline into benzene diazonium chloride by action of NaNO2 plus HCl in ice cold solution is referred to as diazotization. And this benzene diazonium chloride on hydrolysis with dilute H2SO4 that gives phenol plus N2 plus HCl. Thus we have seen in all 5 different methods for preparation of phenol. The next thing is study of general reactions of phenol. On the whiteboard, you can see 2 reactions. One is bromination with pure bromine, that is liquid bromine, and second is bromine dissolved in water, known as bromine water. With pure bromine, phenol plus twice Br2 in presence of carbon disulfide, that is CS2, or CCl4, carbon tetrachloride, at 0 degrees centigrade, that is 273 degrees Kelvin absolute. You get a mixture of ortho and parabromobenzenes. Ortho and parabromophenols. Orthobromophenol and parabromophenol plus twice HBr. In this, orthobromophenol is the major product, while parabromophenol is the minor product. This is the reaction with pure bromine. However, with bromine water, the reaction is different. With bromine water, there is formation of a yellowish brown precipitate of 2,4,6 tribromophenol. Phenol plus 3Br2 in the form of bromine water gives 2,4,6 tribromophenol plus, of course, thrice HBr. Reaction number 3, nitration with dilute nitric acid. On nitration with dilute nitric acid, we get a mixture of orthonitrophenol and paranitrophenol. But now in this case, orthonitro is minor product and paranitrophenol is major product. While on nitration with concentrated nitric acid in presence of concentrated sulfuric acid. Nitration is complete. Phenol plus 3HNO3 concentrated in presence of concentrated H2SO4. We have 2,4,6 trinitrophenol, and this 2,4,6 trinitrophenol is known as picric acid. Remember that picric acid is again one more acid which does not contain carboxyl, that is COOH group. We have seen carbolic acid, that is phenol, which is an acid but not containing carboxyl group. This is one more acid not containing carboxyl group. Next reaction is sulfonation. There are two reactions of sulfonation. One at room temperature, that is about 290 to 300 degrees Kelvins. Another is at 0 degrees centigrade. The products are different. The reactants are same. That is sulfonation. On sulfonation with concentrated sulfuric acid at 290 K, that is room temperature, we get ortho product, that is 2-hydroxy benzene sulfonic acid. And on sulfonation with, of course, concentrated sulfuric acid, but now at 0 degrees centigrade in cold, that is at 273 K, we get para, that is 4-hydroxy benzene sulfonic acid. So remember, this is very important reaction. Sulfonation. But sulfonation occurs in two different ways depending on temperature. At room temperature, we get the ortho derivative, that is 2-hydroxy benzene sulfonic acid, while at 273 K, we get 4-hydroxy benzene sulfonic acid. One more very simple reaction. Reduction with zinc dust, ZNO goes away, H is attached to the carbon of the benzene ring, and on reduction we get benzene. Now one very small thing is remaining behind, that is color test for phenol. It is a test used for distinction between alcohol and phenol. With ferric chloride, phenol gives a color test. It produces violet coloration of ferric phenoxide. Violet coloration of ferric phenoxide. That is C6H5OH plus FeCl3 solution gives thrice C6H5O. Fe ferric phenoxide plus, of course, thrice HCl. This Ferric phenoxide is the violet coloration. There is one more test to distinguish between alcohol and phenol, a chemical test rather. It's a physical test. Just add 2 or 3 drops of ferric chloride, you get violet coloration, say it is a phenol. There is no color test of ferric chloride with alcohol. So from this color test, one can distinguish between alcohol and phenol. And one chemical test is the test with bromine water. With bromine water, we have seen we get yellowish brown precipitate of 2,4,6 tribromophenol, and there is no such reaction with alcohol. So this is one more test, that is a chemical test to distinguish between phenol and alcohol. And this was the color test to distinguish between phenol and alcohol. It is almost completion of this a very small topic, namely phenols. We stop today.